Today we are going to continue. Last week we used two examples. One was a concrete bench. I only drew the concrete bench for you, but in the sketch I did, the reinforcement rods were also in that drawing. I don't know whether you realize that. We will go back to that another time. Then later on, we looked at the connecting rod of a diesel or petrol engine. Could be used for a generator or a truck or a car. And then today, we are going to look at the internal combustion piston, the piston of an internal combustion engine. Maybe next week we'll look at the crankshaft. The reason why this is very interesting is that we would do them one by one, separately, and we'll assemble them together, and then we'll animate them in a working engine, the motions that we expect in a working engine. We will use them to show the power of Fusion 360. While you continue looking at the videos that give you the power of Fusion 360 by telling you what it can do, I want as much as possible that our classes actually would sit down and do those things, not give you another thing to memorize again. So if you are following my class, it will be because you are doing the practical things that I'm asking you to do. And there's an assignment due next week. There's another assignment which I will give you today, which will be due at the end of July. So do not slack in these assignments. The assignments themselves, because this is the practical course, is going to carry close to 40% of the course grading. So the questions that I can ask you in a class do not really test your skills. It is the assignments that test your skills. The dimensions I give you are not cast in stone. You can use your own dimensions. You can even draw something slightly different from what I drew. So as long as you show me that you have the skills to do what I have done, or even to do better, that's good enough for me. That's all I want to see happen. Last week, we used dimensioning and constraint to create something not as complicated as this, but something like this. This is the actual bench that I took measurements of and drew. And I advise you all to have your tapes, your digital measuring equipment, and so many things on your own, not the one belonging to the department, for yourself, that you can take measurement of any equipment or any thing and convert that to a 3D solid model. As you analyze those models, you are going to get stronger in your ability to design and improve on the things you see in your environment using the knowledge of the theories that you are learning. It is the fact that these theories do not connect with reality to create products. That is why engineers are often laughed at in our society. And it is not unreasonable to laugh at us. If we just keep telling people theory and we do not make any influence on their lives, they have every right to mock us. So this is the concrete bench with reinforcements, as we saw what we were looking at last week, but we did a very simple one for the class practice. But you have all these dimensions, so you can go ahead and do something as complicated or even more complicated than this. But I just want you to know that the lines inside there, those are reinforcement there, and the lines outside this hole here is also for reinforcement. There were also reinforcements on the slab and so on. I can give you more information on that as we move on. So we also decided to make components out of this. We made a component out of the base, a component out of the arm, and we can create two arms. Then we make a component out of the bench, and we make another component out of the backrest. The bench shown is an example of a component-based design. Inspection color code here, the different components explicit. These are the arm, base, bench, and backrest. Each component begins with a sketch, and we now create the third dimension through extrusion. In this case, today we are not going to use, we use extrusion, but we use some other ability to create the third dimension. And then we looked at a connecting rod, try to show you how we can use 7 circles. Just do 7 circles and then begin to do tangents to them and do some trimming and and offsetting and several things to get this. And after you have gotten what you want, you can now use extrusion to put a third dimension on it. Now, this, for instance, here we use splines and then so many other things, but at least you will agree with me, this actually looks like the real thing now. But there are practical issues that we can look at. Practical issue is that how does this really work in practice? How does a rod enter this one so that it can enter the piston? Will we cut it, or will we put the rod in it and then clip it on the piston? That is it. How does this big head enter the crankshaft? You will see later that we have to cut this and put a screw here so that this will come in two components that we will put together with bolt and screws. You will see how we do that later on, and I will actually give you a homework to be able to do that after I've showed you what it looks like. In the last picture you saw last week, that's when I assembled everything. And those of you who have had time to look at the video I have, it's a very lengthy video. I don't use those methods any longer because Fusion 360 has advanced, and my knowledge of it has also advanced. So that's why I don't just refer you to those things, because I do them in a slightly different way now. But we will look at this. So what we do today, we will go and we try and create a piston, and I will show you how this one can now be affixed to a piston, and how we can now do an assembly of those two together before we come to talk about the crankshaft. It's a good assembly exercise. So this is the assignment, and this assignment you have up till July 30. You have 4 full weeks to work on this assignment. For this week and the next, we'll do piston and probably the crankshaft. We'll do those two. We continue with the assembly and animation of this into inline or V6 or V8 engines, or even some other interesting engines like aircraft engines. On July 30, we submit your own design and add other things that you have learned in Fusion 360. So when I teach you and I show you an example, I am not expecting a copy. You just give back to the lecturer what he gave to you. That's not what I'm expecting. I give you lectures. I give you examples. I direct you to videos to watch. I want to see in your response to me a combination of all the skills you have now put together as a result of all those things. So I expect you to do far more than what I've done to show you how to do these things. So your understanding and being able to replicate my own drawing is just the first step. Just the first step. That it doesn't end there. It shouldn't end there. Due date is generous. It's July 30. So start working on this thing. Don't be lazy. And just remember, the homework assignment you are given will take 40% of your final group tally. So if you fail this, you get 0 in this, you have basically finished yourself. You failed. There is nothing. You cannot redeem yourself by cramming some things to give me back in an exam. No, it's not going to work. And the word is enough for the wise. I hope you've heard me now. You've heard me clearly. And there are 33 of you, or 30, at least 30 of you in class now. I hope you will take that to heart. So please begin to work on the homework and then use that to prepare yourself to ask me questions in the next, when we meet again. And you are free to ask questions in the chat room or other avenues as you feel like. So today, we are going to look at a sketch like this. This sketch is just made of lines. This line, this line, this line, coming in here, and see it like this, zigzagging here with the proper dimensions, and then comes down here, go here, then here, moves up. This is simple or complicated as you want to look at it. I don't know how you see it. You can say it's simple or you can say it's complicated, but it can be done. So what I will do, I will just show you one way of doing it. The way I'm doing it here is different from the way I did it in the video, and it may be different from the way you will do it, depending on how much you have learned, depending on how much you are learning. As you are learning, you will be finding better ways to do your own stuff. So there's not just one way to do things. Usually, anything you do in 60, there are usually up to 5, 6, 7 or more ways that you can achieve the same thing. So I'm just going to give you an example here. So let us say we have roughly these dimensions for the piston sketch. Okay, so we can, okay, so what we do, let me see where I did that. I don't know why I start like that. I think this slide, this sketch is supposed to come before the last one. So, okay, you know, page 8 is supposed to come before page 7. So the first thing you do is to draw. If you study that drawing very well, you will see that we need to draw 1, 2, 3, 4. It is a good idea to draw these horizontal lines and then to draw these vertical lines. Don't mind me, this line should be longer, at least should meet at this point or longer than that. So it's a mistake that this line ended before this line. It should be. So if you draw, so provided from the origin, you draw the first line at 32, and then you make sure that the distance between it and the next one is 2, and then the next one is 7 away from here. And let me just see whether I did that right. Okay, yes, 7. I hope you can see it. 7 here. So to draw the vertical lines is easy. From here, you draw a vertical line 32 units from the origin. Then you draw another one 2 units before it. Draw another one 7 units before it. That gives you these 3 lines. And then on the horizontal lines, you draw a horizontal line from the origin. When you draw this horizontal line from the origin, you mark 32 units out of it. Then 4.5 units below it, you draw another horizontal line. 37 below it, you draw another horizontal line. 10 above that last line, you draw another horizontal line. And 7, you draw still yet another horizontal line. So you have 1, 2, 3, 4, 5 horizontal lines and 1, 2, 3 vertical lines. So many horizontal lines and the number of vertical lines. You have those there. Now, you make a hand sketch. The reason why we did all of this, if you look carefully, you'll see that there is a horizontal line drawn for this one. There's another horizontal line drawn for this one. There's a horizontal line drawn for this one. And there's another horizontal line drawn at this point. So that by the time we take the vertical line here, plus the horizontal line here, we know what this point is. We also can recognize this point. So all the 1, 2, 3, 4, 5, 6, 7, 8 points of the external circuit of this are recognized. We didn't forget about these ones initially. If we do that, the next thing we do is to turn all these ones, because these lines are not important for the drawing. They are not part of the drawing. They are just to guide us. You want to turn them into construction lines. They will be dash, 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 and the computer will know they are not part of, they are just they are just like scaffolding on our work. So they are called construction lines. You can mark these things and make them construction lines. And I think I better show you how it is done in Vision 360. Okay, so let me just wait and be sure that you can all see my Vision 360 screen. To do these lines, you can always do a line, just pick line here and put the beginning of the line and put the end of the line, and that's it, and put escape. So you can draw a line like that. So it is easy to draw horizontal lines. It will show you that the thing is horizontal by giving you a horizontal sign there. If it is vertical, this sign will be there. So you better know how the horizontal, if it is not horizontal, you can mark the line. Okay, let me just do that line again, and I will make sure initially it's not horizontal. I can do a line. Let us say I do a line like this. And I want this line to be horizontal. All I do is to go and put the horizontal vertical constraint. I put this and I mark this. So you can see that's another way to be sure that the line is horizontal. So if you're not sure your line is horizontal, you want it to be horizontal, you constrain it to be horizontal by choosing, if you choose the horizontal vertical constraint, the Vision 360 is smart enough. If it is close to being horizontal, it will make it horizontal. If it is closer to being vertical, it will make it vertical. If it is somewhere in between, then it will do what it likes. So you know what you want, and then just be careful that you make the right choices at the appropriate time. Okay, so that is how to do horizontal, vertical how to do horizontal vertical in this thing. So now what we want to do now is to turn all of these things to construction lines, not the dimension lines, but the lines we have drawn. The dimensioning is done to make sure we know precisely what positions this thing are. You can see that this one is dimension 32. So this line here is at 32 from the origin. And then this horizontal line is 4.5 below it. And then the last line is 37 below the horizontal, the original horizontal line. Then up 10 there, we have this. Then up 7 here, we have this. You can draw the line and apply a dimensioning. Once you apply a dimensioning, once you apply the dimensioning, it will show you the dimensions, and all these are very easy to do. The next thing I'm going to do is that I'm going to turn all this into construction lines. To turn one of them into construction line, all you need to do is to mark it and press X. If you mark it and press X, you can see that I have made this a construction line. That pressing of X is a toggle. Let us say I have a construction line marked. If I mark a construction line and press X, it turns it to a regular line. So I can use X to toggle between being a construction line and not being a construction line. And I can pick the line one by one. I can also pick two lines. I can choose two lines and mark X, and both of them are now construction lines. Okay, this is a construction line, this is a construction line, and you know by the thing being dot, dot, dot instead of straight lines. So it is the dot, 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 not necessarily the color, but the fact that if it's a construction line, you will see dash, dash, dash. Now, if I want to remove that from being a construction line, I can just mark the two of them. I can just mark it and press X again. If I mark it and press X again, it's now no longer a construction line. Mark it, press X again. So all of them, they are no longer construction lines. I haven't marked and pressed X. So you have, so I've marked and pressed X, so there is not a construction line again. Now, do I have to mark them one by one? No, I can select everything by clicking, by using my arrow key and dragging the whole thing until all the lines are chosen. With all the lines chosen, if I press X now, all the lines that were chosen are now construction lines. So you can see every line here now is a construction line. So every line here now is a construction line. So we have construction lines everywhere. So that is, so one thing, you draw your lines, you put the appropriate dimensions to be sure of where they are located. You draw horizontal and vertical lines. So what is the next thing to do? The next thing to do is to do the profile. Then you can now go back and use the line to do the profile. You do the profile this way. You start from a point and you draw a line to the next point. Okay? So once you've drawn a line to the next point, you can use the marking menu to bring the repeat line. So it gives you repeat line, and you can start from here again, and you get to the next point. Then marking menu, repeat line. You get the marking menu by right-clicking. You go from there to the next point. Again, you use the marking menu to repeat the line. You start from here, you go here. Again, you use the marking menu again to repeat that command. That is from here until here. Then the marking menu again, repeat the line from this point to this point. Then the marking menu again, repeat the line from here to here. The marking menu again, repeat the line, and it is from here to here. What do you now see? What you see is that because I have a closed circuit, it is telling me that I have a closed circuit, because there are many things you can do with a closed circuit that you cannot do with things that are not closed. It is only when you have closed circuits that you can make a solid out of them. It doesn't matter whether you are making the solid by an extrusion, by a lofting, or by a revolution, but there are several other ways you can make your solids. But the first thing about making your solid is by doing a closed circuit. So that is how, so I've showed you now how to draw the horizontal lines. And after you have drawn the horizontal lines, you can now decide to do a marking of what you have done. And then once you have done that, you are able to get a closed circuit. But we are not done yet. The next thing we want to do is to begin to create the positions for the, we want to create the positions for the when you have a piston, you have piston rings. Those of you who have some experience with motor mechanics will know that we have to create the location of those piston rings. We are going to use the rectangle. We are going to create a rectangle. See, I'm going to create a 2-point rectangle. I can create a 2-point rectangle, and I create a 2-point rectangle here. When you are creating a 2-point rectangle, all you need is to give the diametrically opposite points of that. So once you do that, you create it rectangle. So this is a rectangle here. Let me just be sure you can see it by making it big. So you can see this rectangle here. So you have this rectangle. So if these 2 points are on this line, if you are not sure, you can mark the 2 points and just make sure that and then say that you want it to be collinear with that. You say collinear, okay? It says it's over constraint, so that means that it already knows it's collinear. You can either say it's collinear or it's vertical. So this is there. So the next thing for you to do is to come and now put the dimension on this one. So you have to know what distance do you want this to be, what is the width, and what is the length. And now the length, you can create a dimension if you want a sketch dimension, and then you create this, and let us say you want this to be 3.8. So 3.8 there, and then now if I put this and this out, if I want that to be 2.5. Now I also need to decide the anchor point here. What is the distance between this and the edge there? Let me see what I have in my original sketch. In the original sketch, let's see, no, not there. In my original sketch, that is what is that? Let me just see, what is it? Okay, the first thing is 2.8 to the edge. Okay, so 3.8. So let me go and make it 3.8 in the. So I want to make this 3.8. So I take this point and this point, and with the dimensioning on, I say I want it to be 3.8. So it has made it 3.8. You can see that everything turns white now. So it knows everything that is here now. So now, if you look at the drawing, you will see that we need to do 2 more of that. We need to do it 2 times more. Well, there are several ways. You could if you try to copy this, it will take it line by line. You could copy the lines and put them here, but you can also select them whole. What I would prefer to do is to select all the. Okay, let me leave the. I will use escape to escape from the dimensioning. Let us say I select all the lines in this. All the lines in this rectangle. If I select all the lines in this rectangle, and now, what do I want to do? I want to make a copy. Now, be very careful in copying this. I want to make a copy, and I want to put that copy so that there is a distance of 2.5 in between them. So I'm going to choose modify. In modify, I'm going to create move copy. So it says move objects. It knows that 8 objects have been selected. Those are the 4 lines and the constraint and the 4 constraints that it could be the 4 lines and the 4 points. So, or 4 lines and the 4 constraints. It knows everything we want to move. Now, it has selected which objects to move. Now, it is not enough to now say move. If you select the move type, if you can pick what distance it will go. You can pick what distance it will go, but that's not enough. What we want to do is to create a copy of it. In order to create a copy, you have to mark We have to mark this. Let me just see what is happening here. Move. We have to go to translate. And then we are going to make sure that create copy. That create copy may not come up in your form that you are filling. So you may have to scroll down to be able to see it. But if you miss that, you are just going to waste a lot of time. If you say create copy, and then you can now move it. You can now move it. You now must move it to -5. You must move it to -5. Why? Because the width of the rectangle is 2.5. If you want it to be 2.5 below, so that means that this distance to this distance is -5. If you are happy with what you have seen, you now see that because we chose create copy, so you can see that the original thing is left there and there's a copy that we have moved. It doesn't erase what was there before. And if you are happy with that, you can say okay. So you can see that the rectangle we created here has also come here. We can repeat that. We can repeat what we have just done. We can repeat that what we have just done by using the marking menu, repeat move copy. If you say repeat move copy, you must still be, you still have to select the objects, okay? Select the objects, okay? And then you must still say create copy. So here now, we are going to move it to -10 in the Z direction. We're going to move it to Z distance of -10. Oh, I lost it. I don't know why. I struggle with this when I did it on my own. So let me just do it again. In fact, instead of doing the first one, I want to, okay, let me select this one first. If I select this one first, and then I will choose move copy. And then I've selected the objects and I say I want it to be a translating move. And I want it to be a translation move. I want to keep a copy. And I want to move it a distance of, I want to move it a distance of -5 now. So let us see whether it will do it now. It's not doing it. Why? Let me try it third time. Move. Okay, it's Y, it's not Z. It's Y distance. So that is -5. Okay, so okay, so we've got these rectangles. The next thing we are going to do, so you can see this. Don't forget that even if we are wrong in the distances or the spacing, in the spacing or the thicknesses of these rectangles, you will see how powerful Fusion 360 is, that even after you have made your solid, you can come and correct this AI to reflect in the solid. So what we are going to do now, we are going to trim all these places off. So that this line will come like this and go inside, come out, and so on. So we are going to create a cut in there. So we cut this and cut this, cut this. Okay, and then cut this. Okay. There are several lines on top of each other there because of the copying I've done. So if I cut this, okay, there's still something to cut here. That's why that thing is still not changing color. Okay. Now, you will, I don't know whether you can see it. Let me make it a little bit big for you to see. If you look here, if you can see my screen clearly, you will see that the closed circuit is still having this light blue shade. Whereas these places are now open, making sure that there is no closed object here. In doing this, you may find out that you have cut too many things. Maybe you mistakenly cut off this line. When you mistakenly cut off this line, you will be flagged immediately that this is no longer a closed circuit. In my own case now, I can simply undo. If I simply undo that cutting, I'm back to what I want. If you don't, you can just go and take your line again and repeat a line in the place where you have removed the line, and that will be okay. So just know that if what you intend to do is to make this a solid, it has always to be a closed circuit. And if you look at my drawing, this one is thicker than the other ones. So instead of 2.5, instead of this one being 2.5, this one is a distance of 3.8 here. So if I go to create a dimension, I create a dimension here, and I don't know why this is doubly dimensioned. Okay, if I create a dimension here, and then I just create this dimension to be 3.8. I hope it will work. Okay, so that means that there is another thing there. So let me just remove. I have too many lines there. I've created the copy I was doing. I've created more stuff than I wanted to. So I'm going to do I'm going to have some cleaning to do now. I have to cut this off. And you can see in doing that, I have done what I was afraid of. I've done what I was afraid of. I have opened this thing. No problem. This can easily be remedied. I want to remove this. So what I want to do, I can go back, pick up the line again, and I want a line from here. Okay, you see, this is a very delicate thing. So what I'm going to do, I'm going to make this one. I'm going to put this one only near here, and then I'm going to use the constraint. I'm going to take the constraint of coincidence. Let's see, coincidence. Let's see, coincidence, yes. So I want this point and this point to be coincident. So I will use the coincident constraint. So when I use the coincident constraint, then if I now dimension this, if I want to dimension this, create dimension of this one. Oh, this is really, I'm in a big mess now. What I'm going to do is that I'm going to just rub off so many lines here and redo this completely. So I want to redo this one. So I will take this one here, go horizontally in, then go vertically, and then go back horizontally. So what I'm going to do now is that I'm going to dimension these lines. I will take the create dimension. This one is 3.8. This one is also 3.8. And then I want to close it up by taking a line here. So you can see now the thing lights up again. That means that I have my closed circuit back. If I don't have that, I'm going to be in problem. I'm going to have difficulty when I try to do a revolve, because you can only create a solid on things that are closed circuits. Let's see, there's somebody with a chat question here. How did you come about all the lines? Did you come late, Igbinejesu Samuel? Did you come late? How did I come about all these lines? How did I come about all these lines? You are a late comer, and I don't think I should deign your question. I don't want to say it's a silly question, even though that's what it is. The first thing I did was to explain how those lines came about. So we did all those lines before. So there's no need for me to answer that question. So those lines were already there. We not only drew those lines, we also made them into construction lines. Is how do you use the control constraint tool on a circle? Well, we have not done any circle here because there is no simple answer to that. Depends on what the circle is supposed to do. For instance, suppose, let me just do a circle here to answer your question. Let me just do a circle with a constraint tool. Suppose, for instance, I do a circle here. Suppose I am interested that that circle be tangent to both this line and this line. So I can say constraint, and I can say I want a tangent constraint, and I want this and this. So you can see it is there. Suppose I can also say I still want this and this to be tangent. So you can see I did that circle, and I've constrained the circle to be tangent to this line and to this line. That is one way. That is one. Okay, suppose I want to do it. Suppose I want to do a circle, and I want the circle to be tangent to this line and this line, for instance. Or no, maybe not even do that. Suppose I want the center of this circle. Suppose I want the center of this circle to be at this. Okay, let us say I do a circle again. Let me just do a circle again. This is the center of the circle. Suppose I want the center of the circle to be coincident with this point. So I can go and take the coincident constraint, and I want this point, which is the center of the circle, and this point to be coincident. So you can see how I have used constraint with the circle. In one case, I want it to be tangential. Another place, I want the center to be at a position. So that is how you can make it. That's how you can. That's one. There are just too many ways. It depends on the circumstance. Depends on where you are at in your drawing and what you are really trying to achieve. So let me remove those two because they are not part of my drawing. I still seem to be having another chapter. So how do you draw real lines from construction lines? How you draw real lines from construction lines is this. For instance, this is a construction line. This line is a construction. Okay, this line here is a construction line. If I want to make it a real line, I go back again and just press X. So I've made a line. So I've turned this construction line to a real line now. But I don't like that, so I can just undo. So you can make a construction line, a real line to a construction line, or a construction line to a real line. Just all you do, just press X after you have marked that line. If you mark a line, if you press X, if the line was a construction line, it will become a real line. If the line was a real line, it will become a construction line. And it doesn't matter. For instance, let us say I have a circle here. I have a circle here. Suppose let me constrain the center to be in a particular place. I just take this. Oh no. Suppose I take this point and this point. Suppose I mark these 2 points. I choose those 2 points and say they should be coincident. Okay, so this circle is well known. So if I mark the circle and press X, I've made the entire perimeter of the circle a construction line. So the construction line don't have to be straight lines. They can be circles, they can be splines, they can be anything. You can move from construction to ordinary lines, or from ordinary lines to construction. In that, there are other ways to do it. I don't even remember. I don't even know what the other ways are. There are slower ways. There are things to do. But it's so fast that way. That's the only one I know. But if you want to know more, go to some of those help systems that you have on your for your Fusion 360, and they will be they will be you will see them there. Okay, so let me see. I hope all my questions are gone. Okay, so this is what to do now. Now, let's see. Let me move this here. So what do we do next? There are several things we can do. We may want to do some decoration, or maybe we want to create a small hole on top of the piston. Well, we can use a spline to do that. If I have a spline like this, that goes like this, I must make sure though that the spline tangent. We want to make sure that the spline tangent is horizontal. Okay, let's see. Okay. I'm trying to control this spline. So just try and make sure that the spline tangent at that point is horizontal. And once you have, so this, then we might decide to remove, we might decide again to do some trimming, remove the full lines here. We remove the full lines and cut the extra line here. Okay, so you can see again, the closed circuit is there. You may also want to do some measure of filleting if you want. Might fillet. Want to fillet this and this? There's a fillet there. Which, if you accept the suggestion, you might want to fillet this line and this line. You can say repeat fillet. Choose this and this. If you want to accept the suggestion, you can also fillet. You can also fillet. You can repeat fillet. You can choose this one and this one and accept the suggestion there. So that's another fillet there. So everything is still okay. There are several other enhancements you might want to do. So if we look at what is happening here now, I have some problem here. Let me just see. That thing can cause a lot of wahala later on. So there are so many things to trim off there. Because if you don't trim them, they are going to give you trouble. Okay. So you have to trim off useless lines that are not serving any purpose. Otherwise, they can easily lead to problems. They can easily cause problems. Okay, so let me go home now. Okay, so what I want to do, okay, there are some things that were some of my errors in copying, using the wrong things. So I can still remove, I can remove some further things. So I can trim this. Okay, let me just can remove all of this. What else? I think everything else is okay. So what I want to do now is to revolve this along this vertical axis. I want to revolve this along this vertical axis. I want to revolve the shaded thing along the vertical axis. So I must first of all finish my sketch. I finish sketch. Well, so before I finish the sketch, there are some things that are, let me edit the sketch again. I want to remove this extra stuff there. Edit sketch. Okay, finish stage. So you can see a clear picture of what we want to revolve. We want to revolve this. You see, it's very reassuring when you see, before you go to revolving, make sure that the object you want to revolve is a closed circuit. I cannot overemphasize that. So we now say create revolve. So to create revolve gives you a form to fill. Here is the form to fill to create a revolve. So it already knows that, it already knows the profile because we selected the profile. Now it wants the axis. The axis is the Z axis because this thing is beginning at the origin. So the Z axis will do for us. Several ways we can choose the Z axis. We can choose it if the origin is on. We can pick it here. You can see, okay, let me cancel that. So create revolve. We can pick the angle axis to revolve here. Another way, we can go to the browser. Okay, if the origin is not on, or if this is not on, you can go to the browser. You can, if you are at the browser, you can pick the Z axis at the browser there. So again, that is another way to do the revolve because it already chose the angle of 360 on one side and create a new body, which is what we want. So if you accept all of that, you don't forget, you can set this. For instance, you can set this to be 140 degrees. So it doesn't have to be a complete circuit or minus 140. Let me just make it minus 140 to just show you what options you have. So you can have a revolve. Let me accept this and you see what you will have got. So the revolve doesn't have to be a complete circuit. So you can see the object we have created. If we do not use a full circuit, we can revolve and create a partial dashpot, a partial piston here. So this is a piston subtending an angle 140 at the beginning and at the origin. So you see it. So this, you may not find it this as easy as I have done. If you are not finding it easy, let me warn you where your errors may come from. Your error, what you should watch out for to start with is that do you have a closed circuit? And because it's so important, Fusion 360 will let you know when you got a closed circuit. And if you do anything, if you cut anything that compromises that closure, it is going to let you know if you know what you are doing. And you can see what has happened here. You can see that I created some space on top here. In a realistic piston, that space can be used for some other controls inside the piston. So the piston sometimes deliberately has some space here. So that space is what I created that's what I created that time with my spline. So there's a depression there. I can go and edit this feature, and then turn this angle to 360, and I will have the full piston that I'm looking for. So here is the piston now. So this is the piston.